For our final project, we chose project number 1. Our goal was to program a robot to push an object, in this case a tennis ball, from point A to point B. The robot must then return to its original position. We were not allowed to place the object onto the robot. The robot must either trap or pick up the ball itself. To accomplish this, old parts were repurposed and new parts were designed and attached. The track is an L-shaped path, each length being at least 1.5 meters. The beginning and the end of the track were marked with blue tape. The line tracking sensor could not be used, however, the obstacle detector was allowed if needed. For the design, we decided to use the servo from the camera module and obstacle detector to control the arm of the robot. The purpose of the arm is basically to cover the ball and roll it around. It consists of 4 pillars that can push the ball around in every direction. Since we don't need the camera module and obstacle detector for this project, we removed it from the servo and then positioned the servo so that it spins in the vertical plane rather than the horizontal.
The cables for the camera module and obstacle detector were removed as well. We also removed the dead plate so that we can design our own bracket to mount the servo. The brackets are designed in Autodesk Inventor and are just a simple L-shaped 3D print that connects the servo to the body of the robot. The fastener used for the brackets are the same nuts and bolts that are used to connect the dead plate. The arm is also 3D printed with PLA. The hole on the arm that is used to mount to the servo is designed to be smaller than the diameter of the screw. This is because the material used, which is PLA, is softer than metal. So when we are inserting the screw, it will create a tight seal between the screw and the arm. A nut is used to fill in the gap because the screw used is much longer than the thickness of the arm and the depth of the servo shaft. For the arm to cover the ball, the robot must place very close to it. In this case, we decided to use a tennis ball for the object. Here, you can see the ball placed right in front of the robot. The arm starts at the top, then comes down to enclose the ball. You can see that the robot skews to the left when moving forward. Because we couldn't figure out a solution to fix this problem, we decided to just account for it in the code. We will have the robot turn more to the right of the path so that when it is moving forward, the skewing will correct itself.